For number 6, we're looking at the determination of the length of the indicated curve, whereupon we have x is equal to 4/3 of y to the 3/2 between y is equal to 0 and y is equal to 2. Now we have for the function itself, again we have for number 6, we have x equal to 4/3 of y to the 3/2 as y runs from 0 to 2. Okay, now for the first order derivative, we can use, since we had the function already expressed in terms of x equals, we can rewrite whereupon we have for the first order derivative we can express as dx over dy. So if we utilize the power property of the derivative, now we have 3/2 times 4/3 of y, which by then will be raised to the 1/2 degree. So for the first order derivative, we'll end up with 2 times y to the 1/2, or you can express this as 2 times the square root of y. Now, in looking at taking the square of the derivative, okay, this is going to be at 4y itself. Now, in expressing what we have this time around in the determination of the arc length itself, now we can say that we have the integral as y goes from c to d, and we have of the square root of 1 plus the square of the derivative dx over dy, and this time around we're integrating with respect to y. And so we have for the setup, okay, so point C to point D is going to translate to 0 to 2. And we have of the square root of 1 plus 4y dy. And in terms of what we have for the integration, okay, once again, we're going to be looking at integration by substitution. So if I integrate over the square root of 1 plus 4y, or in this case the quantity of 1 plus 4y to the 1/2, again, so if I take substitution and have u to represent 1 plus 4y, and I take the differential on both sides, we have du is equal to 4 dy, and rewriting dy in terms of the substitution differential, we will have dy equal to 1/4 of du. And so in carrying forth, okay, what we have upon executing the substitution, okay, we have for 1 plus 4y quantity to the 1/2, we have u to the 1/2, and in place of dy we have 1/4 of du. And following through with what we have, okay, we have 1/4 of the integral of u to the 1/2 du, and the antiderivative of u to the 1/2 again will be 2/3 of u to the 3/2. We have followed by the constant. Okay, so 1/4 or 2/3, okay, will be at 1/6. And as I look at back substituting, okay, we have 1/6 of the quantity of 1 plus 4y raised to the 3/2, followed by the constant. And so as I go back to the determination of the length of the curve, okay, this is going to be the antiderivative. And so in applying what we have for the numerical integration, so we have for the length itself, okay, we have 1/6 of the quantity of 1 plus 4y to the 3/2 as y goes from 0 to 2. And it's going to follow that for the length of the curve. Now we have with the upper limit 2, okay, we have 1 plus 8 is 9 to the 3/2 will be 27, and 1/6 of 27 we have 27/6. And with 0, okay, this expression is going to become 1/6, and 27/6 minus 1/6 will be 26 over 6. And in simplified form, we can say that the length of the curve regarding what we have in number 6 is exactly equal to 13/3.